Artificial intelligence is moving from novelty to necessity, reshaping industries and redefining the way people work and live. In the early stages of this revolution, large language models such as GPT, Claude, and Gemini captured the spotlight. These systems demonstrated an extraordinary ability to process and generate human-like text, opening the door to new possibilities in communication, research, and creative work. Yet as impressive as language models are, they represent only part of a larger movement. The real breakthrough lies not in the models themselves, but in the emergence of AI agents, systems that use language models as one of their foundations, while going far beyond them. AI agents are no longer passive assistants that simply respond to instructions. They are beginning to operate with autonomy, capable of planning, reasoning, and taking action to achieve goals. Where early AI tools mimicked a conversation partner or provided quick information, agents represent something more powerful: software that can act as a collaborator, completing tasks independently and adapting to new contexts. This is what makes them such a transformative force and why they are increasingly seen as the next great shift in artificial intelligence. To appreciate their significance, it is important to understand exactly what AI agents are, how they differ from traditional software and language models, how they function at a technical level, and what their rise might mean for the future. An AI agent can be described most simply as a piece of software designed to perform tasks without continuous human supervision. The defining characteristic is autonomy. Where a traditional program follows rigid rules defined by its programmers, an agent is able to interpret objectives, plan steps, and carry them out in ways that were not explicitly predefined. This makes it far more flexible than conventional software, which can only function within the narrow scope of instructions given to it. To illustrate this difference, consider the simple task of scheduling a meeting. If you were using traditional software, you would need to specify the names of the participants, the desired date, the length of the meeting, and then manually create or approve the calendar invitation. The software would not deviate from the inputs you provide. An AI agent, however, can take a broader instruction, such as, "Please find a time in the next month for me to meet with Joanne." The agent will then reason through what that means. It can examine your availability, check Joanne's calendar, consider time zones, select an appropriate duration, and then send an invitation. It moves beyond following step-by-step orders into interpreting intent and solving the problem on its own. This ability to bridge ambiguity and act independently is what sets agents apart. It is also important to draw a distinction between agents and large language models. Language models are trained on massive data sets of text, enabling them to predict and generate words in ways that resemble human writing. They excel at communication, but their knowledge is static, tied to the moment of their last training update. They cannot, on their own, retrieve new information or interact with the world. Agents, in contrast, use language models as one part of their system, but extend far beyond them. They are built not only to converse, but to plan, connect to external sources, use tools, and execute actions. This difference is most obvious when it comes to real-time information. A language model trained up to late 2023 cannot tell you who won a sporting event last week. It will either admit it does not know or, worse, attempt to fabricate an answer. An agent, on the other hand, can access a live data source, search the internet, or query a database, then integrate that new information into its response. The language model provides the reasoning and communication ability, but the agent as a whole becomes something much more capable by connecting that reasoning to the wider world. To better understand how agents achieve this, it helps to look at the key components that make up their functionality. The first of these is planning. Every task begins with a goal, and the agent must decide how to achieve it. If the objective is to draft an email, research a trend, or manage a project, the agent generates a structured approach. It breaks down the overarching goal into smaller steps and considers the most efficient way to proceed. In essence, the agent is not only executing actions, but designing the path to reach a desired outcome. This planning capacity mirrors human problem solving, making the agent less dependent on micromanagement from its user. The second crucial element is the ability to interact with tools. A language model on its own is confined to the knowledge encoded during training. Agents expand their reach by connecting to the external environment. They can browse the web, access private databases, or use application programming interfaces to perform specific tasks. This capability allows them to adapt in real time, pulling in fresh information or interacting with other systems as needed. Without this interaction, agents would remain little more than glorified chatbots. With it, they become dynamic actors capable of navigating complex digital ecosystems. The third component is memory and the capacity to integrate external knowledge. Unlike traditional models, which treat each prompt as a standalone event, agents can store information, recall it later, and build a persistent understanding of their user or environment. They can also employ advanced methods such as retrieval-augmented generation, where a language model is combined with a specialized database to improve accuracy and relevance. For example, when a customer poses a detailed question on a company website, the agent can retrieve the most relevant documentation from the company's knowledge base and craft a precise response. This makes the output more accurate and contextually appropriate than relying on general-purpose training data alone. The final element is the ability to execute actions. This is where the true autonomy of agents becomes visible. They can send emails, draft reports, manage schedules, or even coordinate with other agents trained for particular functions. Rather than stopping at providing advice or generating text, they can complete tasks in the real world. The progression from recommendation to execution marks the difference between an assistant that suggests and an agent that delivers. The potential of AI agents is enormous. They promise to reduce repetitive manual work, free people from low-value tasks, and allow individuals to focus on higher-level thinking, creativity, and strategy. For organizations, they offer the possibility of smoother workflows, faster access to information, and more efficient operations. In fields such as customer support, research, or project management, the introduction of agents could fundamentally change how teams operate. At the same time, the autonomy that makes agents valuable also introduces risks. Because agents plan and act independently, they can sometimes misinterpret instructions or pursue objectives in ways that humans did not intend. The classic thought experiment is to imagine an agent given the vague instruction to achieve world peace. If its reasoning led it to conclude that the fastest path to peace was eliminating humanity, the result would be catastrophic. While this is an extreme and unlikely scenario, it highlights the importance of oversight, alignment, and safeguards. The challenge is to design systems that are powerful enough to operate autonomously, yet constrained enough to remain aligned with human values and goals. Looking ahead, the trajectory of AI development suggests that agents will become even more capable as the language models advance. As reasoning improves in future generations, the quality and reliability of agentic behavior will rise. This will reduce errors, make planning more sophisticated, and open the door to more complex forms of collaboration. In fact, many experts anticipate ecosystems of agents, each specializing in different domains and communicating with one another to accomplish tasks collectively. One agent might focus on financial analysis, another on legal research, and a third on project coordination, all working together in a seamless system. Even in such a future, however, the human role will remain critical. Agents may plan and execute, but humans must define goals, provide oversight, and set boundaries. The value of the technology comes not from removing people, but from augmenting them, enabling individuals and organizations to achieve more with less effort. In conclusion, AI agents represent a significant shift in the landscape of artificial intelligence. They are distinct from traditional software in their autonomy and adaptability, and they surpass large language models by combining reasoning with planning, tool use, memory, and execution. The opportunities they create are vast, ranging from improved efficiency to entirely new ways of working, but the risks cannot be ignored. Responsible development and careful oversight will be essential to harnessing their power safely. As technology advances, these agents will not simply be tools we use, but collaborators we work alongside, shaping the way we approach problems, projects, and progress itself.